Most of us are familiar with air, water, and land pollution. But did you know that light can also be a pollutant? Trying to extend the day artificially, we tend to turn on the lights as soon as the sun hides at sunset. We illuminate every street with bright advertisements that try to catch our attention. Light up bridges and roads. Try to keep moving day and night with bright airports. Illuminate factories, greenhouses, and farms 24/7. We will throw light on anything at any time just to increase productivity. Actually, sometimes we even illuminate the sky on purpose, just for fun. One of the reasons we tend to illuminate excessively is to get a security feeling, but light can make you feel safe in places where you're not. More light does not mean more safety neither. By looking at data on road traffic collisions, researchers have found that light intensity had no effect on car accidents. Visibility should always be the goal. Glare from bright unshield lights actually decreases safety because it shines into our eyes and constricts our pupils, blinding us. The glow of outdoor lighting has hidden the stars and changed our perception of the night. We have forgotten that the nighttime environment is a very important natural resource. Above our heads, there is a light show that will take your breath away every night. That is, it will take your breath away if you can see it, because living in a big city, it can be difficult to appreciate a true dark night sky, as when we gaze upon the night sky, the display can be limited by light pollution. Our nighttime skies are full of light that generates a lot of overlooked and even unnoted consequences. When baby turtles hatch at night, they crawl from the sun to the sea, using the relative brightness of the stars and their reflection on the sea as their guide. But when artificial lights outshine the stars, these baby turtles become disorientated. This leaves them vulnerable to predators and even traffic if they head in the wrong direction. Turtles are just one small part of the larger story on how light pollution harms wildlife. Nocturnal animals are characterized for being sleeping during the day and active during the night. The installation of artificial light is probably the most drastic change that humans have made to their environment. Owls are adapted to hunt in nearly total blackness, but lose that advantage whenever there is man-made light disturbing them. Fireflies totally lose their ability to communicate by flashing, and snails would expose themselves to predators in response to artificial lighting. Light pollution also affects human health. We live under much higher illumination levels and totally different patterns of illumination than the ones that existed when humans evolved. Our body needs darkness at night to produce melatonin, the hormone that regulates sleep. But artificial light at night might disrupt circadian rhythm, avoiding us to segregate the melatonin we need. Jet lag is the most common example of the body suffering from wrong melatonin levels. When we travel, our bodies keep sync with our home zone for a while, causing us to be tired or awake at times that don't work in our new destination. But you don't need to travel to feel it. Have you ever noticed how hard it is to fall asleep after using your cell phone right before bedtime? Any type of device with a bright display can affect the quality of our rest and cause insomnia. Sleep deprivation is a very important problem in space. Astronauts try to mimic natural light here on Earth to help synchronizing the biorhythms of the crew on board the International Space Station.
Hi, my name is Ricky Arnold on the International Space Station. We get asked a lot, how do we sleep in space? And it's a great question because we all know how important a good night's sleep is. If you're not getting a good night's sleep, you can count on reduced cognitive function, poorer reaction times, and maybe just being a little grumpy. And up here in space, just like on Earth, those are things we all want to avoid. So, we go around the Earth about every 90 minutes, which means we get 16 sunrises and sunsets a day. So how we sleep is a really good question, because the sun's always getting ready to come up or it's getting ready to set, and we use those cues on Earth to let us know when it's time to begin our day and when it's time to end our day. Well, here in space, we kind of have to do it artificially. So we have these nice crew quarters. It's about the size of a refrigerator. It's very quiet. The space station can be a little noisy, but it's very quiet in here. And we can control light with a light switch. If we are just middle of the day, we have a light like you're seeing right now, which is just this kind of standard lighting. It's getting close to the end of the evening. You want to dim the light a little bit, kind of for the end of the evening. Or if you're going to be up late and you need to keep awake, we have a really bright light setting. The other thing we have is off. You see how dark it got. Another challenge sleeping on the International Space Station, sleeping in microgravity is really nice because you can just float and stretch out and it's really comfortable. The problem is with the air currents in the International Space Station, you could very well float into a piece of hardware and hit your head, or worse yet, even break something. So we got our sleeping bag here, just almost like a sleeping bag on Earth. But as you can see, we have bungee cords that help hold us up against the wall, so I almost sleep standing up. And also, I do have a pillow. It's just a bag full of clothes, but I actually keep it up on the top of my head because I'm a little tall. In the crew quarters, I tend to hit my head on the ceiling when I'm sleeping. So I got my sleeping bag here. I got my bungee cords to hold me in. And then when it's time to go to bed, it's quite easy. Just unzip the sleeping bag, climb on under the bungee cord, climb into the sleeping bag, make sure you're nice and secure, zip yourself up, plan on getting a good night's sleep so I have good reaction times, my cognitive ability is what it should be, and that I'm not grumpy in the morning. So with that, I'm all set. Good night from the ISS.
Just like astronaut Rick Arnold, we should use bright illumination in the middle of the day, dim warm light at evening, and sleep in complete darkness. However, the installation of new lighting technologies, like LEDs, has raised blue-rich white light emissions. Street Spectra is a citizen science project in which everybody can help classifying street lamps just with a smartphone and a diffraction rate. An optical item with a periodic structure that diffracts light into several colors. The task is simple. Find a street lamp and take a picture of it, putting the diffraction rating on top of the camera of your phone. They are very cheap and can be bought online in several places. For this project, we are using 500 lines per millimeter diffraction ratings. Scientists are looking forward to analyzing your pictures. To do it, we need you to upload them to our database. You will need to download EpiCollect 5 app, a tool for gathering your information and sharing it with us. Open it and please give the app access to your Bluetooth. Click on Add Project and search for Action Street Spectra. Then select Add Entry. You will be informed that we belong to Action European project and will be asked to introduce your nickname. The information you will be about to share will form part of an open database, so please choose a nickname that you feel good to be published. Taking pictures and adding them on the go is easy, as the date, time, and even the location will autocomplete. There is a few important details to take useful pictures from the scientific point of view. Take pictures only of exterior lighting at night. Take pics with lampposts far away so they don't saturate the images. Rotate the diffraction grating so that the spectrum comes out diagonally. If possible, try to take the second order spectrum. And please, write down additional characteristics that get your attention. Now it's time to save your entry. You can upload your picture right away or wait until you get home and connect it to your Wi-Fi. Just remember to upload both the data and the photos and add as many as you want. To view and download your data from the server, just go to your browser, visit streetspectra.actionproject.eu and click on Database. In this site, you will be able to see all the details and browse the pictures of all our collaborators. What does a scientist see on these pictures? They can tell the technology of the street lamp depending on the spectral features. If the diffraction pattern is a continuous rainbow of colors, the light source is an LED lamp. However, if it's bright in the yellow region, it's because it's a high-pressure sodium lamp. If it contains a bright violet line, then it's a mercury vapor lamp. Otherwise, the lamp is probably metal halide. Street lamps hunting is also a great activity for schools. We have developed a didactic unit that can help any teacher to introduce the problem of light pollution using both new technologies and suggested activities adapted to 12+ years old students. The lesson plan includes the most efficient way to install lighting sources in such a way that the negative impact is minimized, recognizing the most important mistakes to avoid when lighting. Using more power than needed, pointing the light where it's not needed, aiming to the sky, keeping the lights on when nobody is using them, installing light that is not uniform, filling the night with lots of lights, and changing to bluer light when updating the lighting technology. I hope you send us amazing pictures and enjoy belonging to the Street Spectra team. With your help, we can fight light pollution together. Let's allow stars to awake while the rest of the world sleeps.